2xy dy dx equals 1 plus y squared over 1 plus x squared. So let's separate the variables and integrate and see what we get. So here, leave the dy, of course. The y can stay where it is. The 1 plus y squared can come underneath here. So we can have that. The 2 can go with the x to be underneath the other side. So we get, or we could leave the 2 here actually, and just take the x. So it's 1 over x, 1 plus x squared dx. Okay, so that's what we've got then. That's fine. The 2y stayed where it was, and the 1 plus y squared came underneath to be with the dy. The x moved underneath to be with the 1 plus x squared, like so. So what have we got here then? Well, first of all, this is a function of function. This underneath differentiates to 2y, so this looks like a log. Here, this is going to be a partial fraction, I think. So let's have a closer look at that, shall we? Here, 1 over x, 1 plus x squared. Let's just quickly get the partial fractions. Will be a over x plus bx plus c, isn't it? Over 1 plus x squared. Let's work out these values. So cross multiplied by the denominator. That gives 1 equals a 1 plus x squared plus the bx plus c. Put a bracket around it because we're moving a object from divide to times, cross multiplying, so we get that. Now let's work out a, b and c now before we get back to the problem. What value should we do? X is 0. If we put x is 0 in, we get 1 equals a. So that tells us that a equals 1 then. Good. Now, what else? Should we compare x squareds? So here on this side we'll have 0, x squareds. Here we'll have an ax squareds come out. And here we'll have a b. And there's no other x squareds, are there? So b will equal minus a. So that's minus 1 for b. And then we'll compare x's on both sides. There's no x's on this side. And then there's just a cx here. So that tells us that c is 0. Okay, good. So now we need to write down our integral. Remember what it is? Okay, so 2y over 1 plus y squared on the left. 2y over 1 plus the y squared dy is equal to, what was it? A over x, did we say? See it? On the right, plus bx, c is 0 over 1 plus x squared. So a is 1, so that's 1 over x, plus bx, which is minus 1 over, what was it? X squared plus 1 plus x squared, yeah? See it? 1 plus x squared. Integral dx. Plus and a minus is a minus, so let's just put that in properly. And that's a minus. So everything should be fine. Now this is a log, as we said before. So let's just write down what we think it should be. It's a log of 1 over 1 plus y squared. If we differentiate this in our mind's eye, log goes to 1 over something, which is this, multiplied by the something differentiated, and this differentiates to 2y, so that's fine. Then we get ln x here for the integral of 1 over x, minus 1 over 1 plus x squared is tan to the minus 1, isn't it? That's just from plus a k at the end. I'm just going to check that now, double check that on the table. 1 over 1 plus x squared. I'll just go down the table or up the table. Where is it then? Did you spot it? There it is there, see it? 1 over 1 plus x squared integrates to tan to the minus 1. So back to our original problem. And it looks like that's the answer there. We could get that in explicit form because we could unwrap the log here and then we'd have to rearrange it and then square root the resulting y squared. But I think that's too much trouble. That's good enough for an implicit solution.